minutes. This took, like, the recording was about 20 minutes. I think they recommended, let me see here, for home finance, we were supposed to take 15 to 20 minutes. And that's me talking and explaining and doing all of that, right? That's not just calculating it. So we're doing pretty good. Probability. There are 12 red and 28 blue marbles placed in a box. State the probability of randomly selecting a red marble. I mean, this is as easy as it comes, right? So we have 12 red out of 12 plus 28, right? This is my total here. So this would be 12 over 40. That's it. Don't simplify, don't reduce, and don't ask for it. We'll just move on, okay? B. This one is probably more challenging for some of us. State the odds. Okay, that's worth highlighting probably. We have probability up here, so we're expecting a fraction, but it's odds. And the word against, choosing a red marble. Odds tell you that you're going to have to use this, colon, right? Odds against red, that means that red is here and not red is up front, right? If it's against the event, then that event goes to the right side. So how many reds do we have? 12. How many are not red in this case? 28, the blue ones, right? So it's just like that. However, you could have used this probability to come up with that. You go 12 goes here, and this would have been 40 minus 12. So remember, them added up always gives you the total for the probability. Okay, let's keep going. 2 marks for this page, 1 mark for the next one, and the whole page is empty. This is unbelievable, right? How much space they leave you. State the probability of randomly choosing the letter B. Again, state not the odds, the probability. And the word state is there, which means it's not going to be a whole lot of work. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. And how many B's are there? 1, 2. There are 2. That's it, 2 out of 11. Move on. That took probably a second. 3 seconds to answer that one. Okay, next. Probability is probably where you're going to gain some ground. This is the one that students, I don't know what happens here. And I'm going to try my best to do this one more time with you guys. Maybe one more after if I find the time. But Howard spends $1.55 on each food sample he gives away at his restaurant. There is an 80% chance that after tasting the sample, the customer will order the new menu item. Howard earns $20 for every new menu item that he sells. And here it is. Determine the expected value. That should tell you something of the food sample. Let me see, is the expected value on this? Yes. But I don't like this formula. I do not like it. Okay? But that's in essence what we're going to use here. So expected value. Write this down. I'm going to have this. I'm going to have a probability there times some sort of gain. And then I'm going to have to go minus the probability of losing times some sort of loss, right? So probability of win, this is gain, this is probability of losing, and this is loss. There's only either winning or losing in this case. There's nothing in between. What's my probability of winning? What does it say here? There is an 8% chance. We'll use a different highlighter. There is an 8% chance that after tasting, you will order the new. So basically, from the restaurant owner perspective, there's an 8% chance that you will win. And how much is the restaurant owner going to gain from this? 20. However, how much does it cost the owner to actually provide that sample? So I will highlight the 20 and the 155 because they kind of go together. So you never get the full price. There's always going to be some cost associated with it. So this will be minus 155. So you're going to gain $18.45. So you ready for this one? If there's an 8% chance of winning, then what's my chance of losing? 92%. You got it. Okay. The percentage of all the wins and the losses have to add up to 100%. No doubt about that. So you would only be losing $1.55. So the loss you subtract here to get the gain, that's the number that comes over here as well. So let's clean that up because we can't have percentages. I'm going to go 0.08 times 20 minus 155. That's 1845 minus 92 divided by 100. I don't think it's going to be a shock there. 0.92 times $1.55. 3 marks for this, so you got to be careful. I think they give you 1 mark for having this correctly, like the win and the loss percentages. Then they give you 1 mark for subtracting the 155 from the 20. And they'll give you 1 mark for calculating this. So let's calculate this. Oops. There. 1845. So that's 148. I don't know if it's minus or plus. We'll figure, or it is minus for now. So, but my final answer is 143. So we're going to go 1.48 minus 1.43. Your final answer is a dollar amount, and it is positive, right? I'm going to emphasize that it is positive here. Expected value is 5 cents. Justify whether Howard should be offering the food samples based on the expected value. And you will say, yes, why? It's positive. That's it. Don't tell me the number is big, the number is small. I don't care. They don't care. So I would say, yes, he should, comma, since the expected value is there you go, positive. So remember, yeah, I know. I just wanted to drive that. So expected value, if it's positive, good. If it is negative, bad. That's really what it comes down to. You're going to come across more expected values if you do the other exams. Okay, so it's important for you to do that. Keep going. Random testing of golf balls shows that 100 out of every 5,000 are defective. State the odds in favor. So odds tells you what? It's going to be like this. In favor of what? Of a golf ball being defective. So odds, you know the format. In favor means that whatever the event is going to come up front. So we're going to go defective versus not defective. So good ones. So bad ones versus good ones. That's really what we're comparing here. All right. So how many defectives are there? Defective. 100, right? Yeah, it's all good. And what goes on the other side? Yeah, so I'm going to go 5,000 minus the 100. Because if there's 5,000, 100 out of every 5,000 are defective, then if it's 100 that are defective, then 4,900 are good. Okay, so just leave it like that. Do not simplify, don't do anything, just leave it like that. Next, state the probability of a golf ball not being defective. So first of all is probability. It's going to look like this. A number over total. Always. Okay, there's always the total underneath, always. So we know that the 5,000 is going to go down here, guaranteed. What goes up top? Which should be 4,900, that's right. So 49 are not defective. 4,900. So I'm actually going to use my previous answer to help me out here. If I hadn't done that before, then you would have had to calculate that, right? That it's 4,900 that are not defective. They're messing with the wording. You notice that? When you say not defective, good ones, right? So try to translate it. If that messes with you, try to translate it in such a way that you're like, oh, okay, they're asking for the good ones. Okay, so this page is worth 3 marks as well. So a company produces 80,000 golf balls. State the expected number of defective golf balls. What are they asking here? Do you remember predictions? Do you remember predictions? Okay, predictions. We will multiply the probability of defective times larger sample, I called it, I think. Some of you might have this on your study sheet. And we know that the probability of defective, I feel like this should be a 2-mark question if you ask me. 100 out of 5,000, but they gave you this at the beginning technically. They told you this at the very beginning. And the statement at the beginning to say 100 out of 5,000 are defective. So we're going to multiply this by 80,000. Grab your calculator. 100 divided by 5,000. That's 2%, right? 0.02 times 80,000. That's 1,600 golf balls. If this had been a decimal, make sure you round to the nearest whole number. Okay? They usually stay away from that because they want to assess, like, do you know what you're supposed to do here? So they make the numbers work out to a round number, but it could be different. All right, keep going. I know I'm going a little fast. I know that. I'm watching my time here. The Teddy Bear Factory hosts birthday parties where children can build their own teddy bears. They offer 4 different party packages that are equally likely to be chosen. Their sales during the last month were as follows, right? The Smith family would like to book a party. State the experimental probability, keyword, experimental probability that the Smith family will choose the yellow package. What is experimental again? It's based on actual trials or actual data that what actually happened. So I'll say that this means based on actual trials, right? Based on what actually happened. So we got to go like this. We use this information to answer. Let's add this up. 18 plus 34 plus 16 plus 12. That's 80. 80 trials. And how many are yellow? 12. That's it. 4 marks. State the theoretical probability. Dun, dun, dun. The theoretical probability that the Smith family will choose the yellow package. What should happen? What should happen? One out of four, right? There's 4 packages, 1 out of 4. But you know what statement they had to include for this to work? Go back to the original statement way at the top. There's something they write you there that tell you that, yeah. Ask, go for it. I added up that this is 80. So 80 trials. Did you add it up and it wasn't 80? I'm pretty sure it's 80. If it's not, let me know. This is 40, 50. You're good? Okay, thank you. Hey, that lets me know you're following along actually, so I don't mind that. We're done probability. Yoo-hoo! Yay!